Hello.
Hello, am I audible? Hello.
Yes, sir.
Yes, sir.
Okay. So from beginning, I want to show you some panel diagram. Okay. So this panel diagram is very much important for our industrial job, because whenever we go for any industry, then we have to know some control panel. We have to face the process. So what will be the job or the job role for an engineer for a specific plant? Actually, there is some panels, some control process mainly are coming from foreign country, but they did not provide the all-time maintenance. They are providing only the machine and one-time demonstration. So it's you have seen in previous slides here. Look, this is your substation. Okay, so you easily know these things. Yes, this is transformer, this is CTPT, or these are here. But in this case, you can't understand these things, because this is a purely automation and instrumentation panel diagram. And if you don't know these symbols and where you have to know, if you don't know the sources, then it will be difficult to you to understand, because especially maintenance jobs are very much uh, available to our country, because production purpose there is another job, but production house are very less. But reality, we are India generally producing professionals. Okay, throughout this world, we are producing 33 to 36% of professionals. Means we are producing engineers. So what will be the engineer's job? Sometimes they are introduced in R&D section, and sometimes they are, and some not sometimes, maximum time they are involved in uh, process field, where we have to maintenance. We have to maintain. Say your processes remain fault, so you have to check it, then solve it. This is the main payroll. Okay, so we have to know the panel diagram, and we have to study the panel. See, here your valve is just showing fault. So you can see the 1, 2, 3, 4, 5, 6, 6 number valve is problem showing problem. So you have to know what is the others connection. Then we have to going to the back checking. One by one you have to check where the panel is going on, connection is going on. Then after some time you can find a fault, then you have to replace it or solve it. Then it will again first start it. So in this way, very frequently we have to need some maintenance, and this is our main target. That's why we have to know the panel diagram. Another panel I want to show you. Look, this is a process control panel diagram. Okay, here if how a process is going on, or what are the connection of this process, we can know from this diagram, but we can't understand what are they want to say. Say this is a controller symbol, this is a valve symbol. Okay, and this is something process is going on, and which type, if pneumatic, hydraulic, or electronics, or electrical. This which type of signal is passing from this here to here. This is given by this symbol. So we have to know some symbols and some rules. This is going under the P and I diagram. Okay. So next I want to show you some symbols. What are the symbols? And then I am going to the PI diagram, how to understand and how to draw a PI diagram. Okay. This is it is under your module 4. Okay, and I am going to the backward direction, uh, because these are the very important things. That's why, and interesting also. That's why I am doing this very beginning. And after then, I will go for the instrumentation section. Guys, here is our some signals, and then we go for the here is this is the symbols. Then we will go for P and I diagram, not PI diagram. This is P and I diagram. I will explain why this is PI. Look, this is some instrumentation symbol. You have frequently you have seen this. This is push button. Okay, push button signal symbol. But what is the push button? This is the NC contact. Look, this is the NC contact, because normally open, normally NC, normally closed. And if this push button in this way, then it is NO push button. Okay, just draw this, because after few times you have to know this. Look, if this type of symbols is coming, this is not enclosed, this is open. Okay, this portion is open. Look, these things, then it is called selector switch. Okay, if there is, then it is called solenoid valve. So LE solenoid valve, and you already know this is NO contact, this is NC contact. Okay, normally these symbols, or this type of symbols, in your PLC ladder logic you have seen this type of symbols are there, but this is maybe round symbol. Somewhere some PLC provide this type of round symbol, somewhere it is given in this. This is called coil. This is called limit switch. And This is NO type, okay, normally open. But if this type of position is there, then it is called NC. Look, this is NO. If you push over here or something is there, then it will only come to the contact. But in this case, this is already at the contact. But if you push or give some pressure, then it will go for the disconnect. So this is the NC. Normally close, then it will be going for the open. Okay. And the symbol of relay. If there is a this type of symbols you get, then you get this type of relay. This is the symbol of relay. So there is a lots of symbols is also there. So this is the first basic symbols for your or P and I diagram, and I am giving you some more symbol for the controller also. Then we can find the panel diagram. Now here is some location P and I diagram. Panel and instrument. Look, if any controller or any instrument showing in this type, so this is called primary location, normally accessible to the operator. Say this is and the front panel, may operator can operate it. Then this is given in this symbol, but this is a field mounted. So this is given only this type, and it is auxiliary location and normally accessible to the operator. Then it is given in this symbol. Okay, so this is the discrete instrument. Instrument. It is located at operator. It is located at field or field mounted, or it is auxiliary, means accessory, or say something it is the emergency purpose. Okay, so if any instrument the position is in this area, then you have to mention in this way. Okay, it is shared display and shared control. Next one is okay. So this is the symbol, but if there is between one line is there, then it is located at the operator. If there is a field, so you have to put just like this, no in between, no lines is there. If there is an auxiliary, you have to draw this symbol, and then two lines are there. Okay, So just remember, one line indicate in between, one cross line is indicating it is situated at the operator location. If there is a field, there is no lines between among this. If there is auxiliary, then we have to put some two lines is there. Okay, then it is coming computer function. So some programming function is there, then you have to, this is the symbol. So if it is at the operator, then just cross it. If it is at the field, then don't cross it. If it is at the auxiliary section, then you have to double line you have to provide. Okay. Then programmable logic controller. If your PLC is there in your panel, you have to show your PLC. So symbol of PLC is just square, and then in between a rhombus is there. This is the symbol of PLC. Okay, this is the symbol of your programmable logic controller showing in your panel. But if it is at the uh, operator's hand, then you have to cross it. If it is at the field, don't cross it. If there is an auxiliary operation is also operated, then it will be double crossed. Okay, now we have to know some pipelining. In your previous slide, you have seen there is some panel diagram. Look, once again I want to show you. Look, this is a process panel diagram. So how could I know which things are given? Look, this is only circle is there. So this is, you can see, this is at the operator, sorry, no cross section is there. So upper portion field process area. So you can see this is field process area. But here you can see double cross line is there. So double cross line is there means there is the auxiliary situation. This is also field area, and this is only at the auxiliary, either operator section is there. So you can understand. Look, this line is, one line is given, but two cross line, small line is crossed here. What does it mean? It is meaning that it is a pneumatic signals. There it may be hydraulic signal, it may be electrical signal, and it may be capillary tube, some field signal is there. But here this cross line means, double parallel cross line means there is a pneumatic signal. So you can understand, if you know this symbol, then you can understand, yes, this is a pneumatic signal, or you can say pneumatic, but it is actually, it is uttered as pneumatic. Now again I am going to the signal symbols and signal PI diagram. Okay, so whatever you can see this, you can verify this from the real-time panel diagram. So here is some the line symbols. This is called the line symbols. I'm going for the new slides. Open. Sorry. So this is called the line symbol. Line symbol. If there is a one single line is there, say there is a one single line is there. So this is called, I am giving, This is one. Okay. Connection always process supply line. Sorry. Supply. If it is look like this, say just previous in your panel, you can see this type of lines is there, parallel line is there. This is called pneumatic line. Means in this channel, air is
Air
flowing.
pressure.
Yes, yes,
Air is pregnant.
air pressure, but as a signal, not your, just like your JCB, just like your valve actuator, it is also operated it in your air pressure, but this is a power line, but this is a signal line. Okay, a very capillary small tube are flowing, just like a blue color tube you can see. Through this uh, line only air pressure is going for a control purpose, not any power purpose. Just your in your loco, there is a all a wheeler are braked by a pneumatic power supply. Okay, so pneumatic power supply is not showing this. This is only signal purpose. Okay, says electrical, sometimes electric is used for signal, just like your telephone, but sometimes it is used for power, but this is for your signal, so that's why it is called pneumatic. Pneumatic actually spelling is p pneumatic, pneumatic, but you have to utter that pneumatic, p is not here. Now third portion, this type of symbol you just you have seen in this panel, and if there is a electrical signal, so here is some electrical signal, then you can, sorry, there's just dotted line is there, just dotted line is given. If there is a dotted line is given, so you can see there is a electrical signal. So electrical voltage is given as somewhere it is 0 to 5 volt, 0 to 12 volt, DC, all are DC. Whenever it is given, generally 99% cases it is used as a DC. And sometimes it is used this is 4 volt to 24 volt, etc. Sometimes 0 is not used. Some another voltage for the higher range of voltage, some another voltage is used, because if your line is break, say it is cutted anyhow, then also it is given 0. If there is a signal is 0, then also it means that is a 0, no signal. So how a controller can understand which one was happened? So that's why we are this 0 is called dead voltage, and then we are using any 4 volt or 5 volt as a 0 signal. Okay, and another signal is applicable, that is hydraulic signal. So in first time it was introduced a hydraulic signal. Hydraulic signal means there may be this is we have to say, and this is the hydraulic signal. Look this symbol, this is a straight line is given, but some this L type symbols is there. This is called L type L type letter is you have to write over this. This is called hydraulic signal. In the first time when control system introduced process control, then hydraulic system was introduced first. But what is the difficulties with this hydraulic signal? There is a leakage of hydraulic materials. There is some petroleum lubricant or liquids are used, or somewhere maybe some water with some materials coagulant was used, but what was the leakage was happening. That's why say this is a cotton industry. Some liquid or some petroleum are dropped on this cotton. So what happens? Total uh, production was damaged, or some production was damaged. Say this is a biscuit factory. If there is a hydraulic system is used, then some due to leakage, some materials was damaged because some lubricant was dips on this product. So then we are introducing, first scientists are introducing a second case, the pneumatic signal. In this pneumatic signal, there are also some leakage is there. But what happens? This is only air, fresh air that is coming from a compressor, and after compressor, it is passing through a filter. So this is a normal fresh air. I am not saying that without pollutant is there. No pollutant is there. Just 1 minute. So after then it will, if there is any leakage, so it not affect your process, because say there is a your cotton is there. What happens? Normal air is coming with the contact and no harmful effect was happening. If there is a biscuit factory, some doughs are there, some food products are there, nothing will happen. But air pressure is coming now. Air pneumatic signal is coming, but pneumatic controller is very much difficult, because sometimes it is accuracy and perfection is not so good, because if there is some losses of pneumatic pressure, then it will not operate it. So then we are again introducing the electronic signal, or you may say this is the electric signal. But in your industry, electric signal is applicable only for your control system. Okay, control signal. But whenever say you have to open your or valve actuator, then if you use electric drives, electric actuator, etc., then it will cost is very much, and all time you have to put some electric field. So with a process control process, with a machine, it's actually in a process there is a lots of machines is there. So surrounding this machine, if all electric field is there, then operator could not work freely, because it will be causes chances for the shocking, or some stray field is creating. So then what happens? Only control signal is used, electrical signal. But when power signal is required, then we are use either hydraulic or pneumatic. Okay, so this is a hybrid model for the new industry, because whenever say we have to put pressure in your valve, so actuator can run in 5 psi. So if you apply this, replace this 5 psi with say electrical power, it's a lots of power is required, and all time you have to supply this. Okay, so not required that when we need then we start, no. So this is so 5 psi is replaced by some 5 ampere current when it is flowing through the line. So it causes so many magnetic field, hazardous area, and lot chances of shocking or human fatal. So only power section we are using pneumatic signal, but in your control section, say your control panel, then only use your electric signal. So what is the requirement? So I to P converter, some after some days you can see this is I to P converter, means electrical to the power, P for pressure converter, and this is new, it may be pneumatic, may be hydraulic. So this type of I to P converter or somewhere P to I converter is required, because electrical signal is converted to the P. So these are the requirement. And another symbols is there. Internal system link, software or data symbol is there. If you say this your internet, your PLC is working with maybe a remote position, then it is called, this type of signal is called software software or data link. Okay, and another symbol is there, important signal is there. uh, this type of signal is there. This is electromagnetic signal. Magnetic line, electromagnetic line or sonic signal. Okay, another symbol is there. If you any panel, you can see this type of signal. This is capillary tube. TUBING. Okay, this is capillary. So these are the signal symbols, and then we will go for PI diagram. Another is, look, you can see if there is this type of, then it is called locally mounted. If this type is there mounted on the main board, sorry, on. If this type of symbol is there, any instrument, it may be any instrument, it is solenoid. Look, whenever solenoid is given, solenoid valve is given, then you have to symbol is dotted line. Dotted line means there's the electrical line, and this is a contact, that is solenoid. Uh, there is a few, two or three symbols, important symbols is there, only one is there. First, when M is written, rotary motor. Electrical signal. Look, this is the signal. This is the signal line, not power line. Okay, and there is a power line is there. Power line is, first time you have seen straight line. It is the power line, but this is a dotted line. Means motor is given some, getting some signal from, say, maybe drives, maybe PLC, maybe any other controller. This is pilot light. One type of indicator, but it is called pilot light. If any switch, somewhere you have seen some switches there with some indicator light. This type, whenever light is indicating, but it is working as switch also, then it is called only pilot. Otherwise, normal light or normal indicator. Say your computer power line is glowing. Okay, uh, your start button is there. Whenever you push, then it will glowing. So this is a pilot light, because it is also indicating. Okay, and if there is a KI, then it is called clock.